Okay, so this is 3.4 applications of set theory. So before we go on, there is this thing that's called the principle of inclusion and exclusion. All right, and this ties back into 3.3, and it'll be helpful again in 3.4 today as well. So what it states is the number of elements in the union is the same as the elements in the two sets subtracting the intersection. Okay? So remember the union here, that's everything. That's all of this. All right? And what it's saying is to calculate all of this, is that you, I'll draw one more over here, the same thing. This is A, this is B. So what you do is you're going to double count where they intersect. You have A here, right? And you have B here. Now if you notice where they intersect, that little piece here, you've colored twice. So you've actually counted it twice when you count your numbers. So what you do is you figure out what is exactly in here, and you subtract that amount. All right? So to do that, all you need to do is just kind of stick to this formula here. So all of it, A intersect, or A union B is the same as you calculate all of A, all of B, and you subtract what A and B have in common, because you'll double count it. That's what we were doing yesterday in 3.3, when you had to figure out how much you were over by. And however much you were over by is how much you double counted. All right, so let's do a quick example here using the formula. A total of 20 students are on a field trip. 13 are wearing sunglasses, 6 are wearing a hat. 5 are wearing neither. How many students are wearing both? Okay, cool. So what we know is we have sunglasses and we have a hat, right? We know that 5 are wearing neither. We put the 5 out here. So that means if we go 20 minus 5, we have 15 left over. And what that 15 is actually the number of people that are wearing sunglasses or a hat. So that's everybody left over. So that means here, here, and here all have to add up to 15. Okay? And that's actually this part of the formula. Okay, this is just a formal way of how we did it yesterday. So now you just go, okay, so I know S intersect H is just equal to the number wearing sunglasses plus the number wearing a hat minus the people that are wearing both sunglasses and the hat. Okay? So if I know I have 15 in total equal to 13 plus 6. We know 13 plus 6 is 19, really, so we know we're over by a amount. And this is going to be minus X, right? That's the amount that are wearing both of them. So if we see here, well, we got 19 minus X equals 15. If I figure that out, I know X equals 4. So there are 4 kids wearing both. So 4 goes in here. So that means other kids wearing sunglasses, I have 4 counted for, but there's 13 in total. So all of this has to equal 13. That's going to be 9. And I know that 2 over here will be wearing just the hats. And if I add those all up, 2 plus 4 is 6, plus 9 is 15, plus 5 is 20. So there you go. That's how this works here. And we're going to be using this a little bit later on today too. But, so what we're going to look at today is one of the applications that they like to ask about is a little bit of this, where you'll be using this formula. And yes, you're given this formula on the test. Is that there's another set of Venn diagrams that we like to use as well. And these will be Venn diagrams that are 3-ringed. Okay, so a 3-ring Venn diagram tends to look something like this. I'll draw a small scale one here. You have 3 pieces of information. You're going to have 3 pieces of, you're going to have 3 rings that overlap. Okay, so what you need to do is you need to know all your sets and subsets. You need to know what you're solving for. You need to make a sketch of the Venn diagram. You'll have to use a formula to solve for variables using the principle of exclusion and inclusion. So that's just the formula I gave you there. And I'll show you what the formula is for a three-ring diagram. And yes, you can keep that for the test as well. And then you solve, okay? So what we're going to do here is we're going to create a Venn diagram of the following data, okay? So 750 students, they collected data on how 750 students travel to school. So 370 take the bus, 100 of them bike and use public transportation, so that's the bus again, okay? So just say bus, just so there's no confusion there. We know 80% of students walk and take the bus. We know 35 students walk and cycle. 20 students walk, cycle, and use the bus. 445 students cycle or take the bus. And 265 students walk or cycle. All right, so you need to remember that these terms here, and or, right? And remember, is the intersections, or is the union. Remember now. So the intersection is just what they have in common. The union here is everything between them, okay? So let's create a Venn diagram for this guy here. So I'm going to draw it nice and big down here. I think there's lots of room for my three-ring diagrams. It's got lots of information to get in there. Okay? And then we'll just label them bus, cycle, walk. So I always try to find a piece of information that I can use that's going to incorporate everything at once. All right, so either it'd be like a group of kids that do none of these, or something that uses all three of them. And it says right here, 20 students walk, cycle, and use the bus. So that's the people that actually looks like this. B intersect C, intersect walk. All right, and that is right here. That's what all three of them have in common. Okay, boom. Now, the next one I'm going to look at is I'm going to try to use up all the ands. I want to try to find these three pieces of information here. Okay, so if I know 35 students walk and cycle, so walking and cycling right here. That's everything that those two have in common. All right, so 35 that walk and cycle, that goes all of here. All of this has to add up to 35. Since I already know that I have 20 counted here, that has to be 15. Because 20 plus 15 equals 35. All right, now 80 students walk and take the bus. So that's all of this information here. I've already counted for 20 of them, so that means another 60 of them need to go there. Okay. And we know 100 people bike and use public transportation. So again, that's and. So that goes here. So that has to put this at 80. Okay. Because 80 plus 20 gives you the 100. All right, cool. So now let's look at some other information. So far I've used this piece, this one here, and this one here. All right, so let's look at this one right here. Okay, 370 students take the bus. So what that means is all of this here in this ring of my diagram has to add up to 370. Okay, so I would take a calculator now and go 370 minus 80 minus 20 minus 60. So 370 minus 160 should give you 210. So that 210 represents students that just take the bus. So a way to write that would be from here and the bus minus C and W. Okay, sorry it's a little messy. But now that I have that one taken care of, I could look at this one here, 450 students cycle or take the bus. So that means all of this here plus all of this here because it's or. So that's everything, remember. This would be, oh, it's for bus, sorry. Oh, bus and cycle, no, those are the right ones. So that is everything. So that would be this here, everything. Okay, not just the intersection. No, sorry, that should be bus and cycle. Sorry guys, I'm dyslexic. Okay, so that'll be everything. So if I know that this 450 has to add up both of these rings all together, everything in them. So that would be, I'll mark in red what has to add up to 450. 1, 2, or sorry, blue, 2, 3, 4, 5, 6 rings. So what I'm going to do is I'm going to go 450, 445 minus 210 minus 80 minus 20 minus 60 minus 50. And that'll give me just the people that cycle it. So let's see here. You should get 60. All right, cool. Now this last one, 26 students walk or cycle for 265. So that means all of these guys here for cycling and all of these guys here for walking have to add up to 265. So 1, 2, 3, 4, 5, 6. So I need to know what this one is. That'll add up to 265. So all I'm going to do is just take these numbers in here and add them to 265. That's going to give me 30. Now what I need to do is I need to find number of students that don't do any of these. Maybe their parents drop them off. Or maybe, you know, they, I don't know, skip the whole way there or take their Vespa. I don't know. So we need to figure out how many do all three, which is easy peasy because we know the total amount of students, right? So now all we got to do is just figure out what's left over. So now you just take each one of these totals. We're going to go 750 because that was our total amount of kids. See what we have left over. All right. Maybe we don't. Who knows? But let's just try it. So I'm going to go 750 minus 210 minus 80 minus 20 minus 60 minus 15 minus another 60 minus 30. So the amount that I got left over that don't do anything of these ones is 275. I shouldn't have circled that. It makes it look like a set. It's just going to be 275 out here in my universal set. Okay? So that's the first example. Whenever you're doing this stuff, always work from the middle and then work your way out. Okay? Now, in some cases, that's not always going to work out so nicely, unfortunately. It's kind of a pain. But it's possible. All right? And it is possible if we apply the same kind of principle from this formula here, where you take the union and you add up each total and then subtract the intersection. The only problem is you got a heck of a lot more intersections here to work about, okay? Because if you notice, like this 450 students, that was counted twice. So I counted a lot of stuff twice, maybe even 3 times. So the formula for this one is a little more complicated. Well, not even so much more complicated, just a little bit longer. So, to find, so the formula for this one is, if you want to know the number for the entire union, I won't use a specific one, the number for any 3-ring diagram, try this one more time. So, just take your total for all of A. Now, A, B, and C could be any letter. It doesn't necessarily always going to be that. You're going to take the number for C minus the number for A, B minus the number for C minus the number for A, C, and then you're going to add. So what you've done now is you've taken each individual ring, added them all together, right? We added this ring, that ring, and this ring, all together. And now what you've done is you've also subtracted this piece here. And then you're subtracting this piece here, and this piece here from everything. But what you've also done is you subtracted this guy 3 times. So what you got to do is you got to add that back in. So the very last tail end part of this formula is you then go back and add the middle intersecting piece. A, U, B, U, C. Okay, so I'll do an example here to show that and what that looks like, and then we'll move on. Okay, so use the following clues to answer the question below. 28 children have a dog, a cat, or a bird. 13 have a dog, 13 have a cat, 13 have a bird. So if you add those up already, you have 39 animals. So that doesn't quite make sense when you've asked 28 kids, so there's clearly some overlap. So what we know is 4 children have only a dog and a cat. 3 children have only a dog and a bird. 2 children have only a cat and a bird. No child has 2 of each type of pet. So we don't have 1 kid with 2 dogs or something like that. So let's look at this first. Draw out our Venn diagram. So what we want to do is we want to know how many children have only 1 pet. All right. So we draw our Venn diagram here. I'm going to make this here. Let's go bird, cat, dog. Okay. So now what we know is, we know the total for each total ring. Like we know all these numbers here for birds have to add up to 13. We know the same for cats, and we know the same for dogs. We also know, but what we want to find out here is, we want to know just the amount that have a bird, just the amount that have a cat, just the amount that have dogs. Okay, so we're looking for these numbers here. That's what we're trying to find. I'm just going to clean this up. I've drawn a lot of lines. Okay, so this is what I'm looking for here. Number of birds only, cats only, dogs only. Cool. So let's see what we got here. I know 4 children only have a dog and a cat. So dog and cat is this ring right here. And that's 4 of them. It doesn't say they only, because it stresses only, that means it goes there. All right, and I know 3 kids have a bird and a dog. So I'm going to put that one here. And I know 2 children have only a cat and a bird. Okay. Now, if it would have said 2 children have a cat and a bird, that would be all of this, or all of this here. But since it says only bird and cat, it can only be this one here. Okay. So now, if you look, I always said start in the middle and work your way out. Unfortunately, we don't know what this number is. Okay, so we got to figure that out. So now we're going to go and use our formula here. Okay, instead of ABC, I'm going to use birds, cats, and dogs. Okay, so I know the number all right, so number of birds. Birds, baby cat, baby dog has to equal number of birds plus the number of cats plus the total number of dogs minus the number of birds and cats minus the number of birds, dogs minus the number of dogs, cats plus the amount of birds, cats, and dogs. Okay. So remember now, we've put these together. So I know the number of birds, I know the number of cats, I know the number of dogs. The number of birds was 13. The number of cats was also 13, plus the number of dogs is also 13. The number of people that own a bird, a cat, and a dog, that's what I don't know. That's my unknown. That's my X. Okay? I'm just going to scroll up for a second here. Let's talk about birds and cats. Which is a terrible idea because the cats eat the birds. These people are monsters. Why would you do that? If I look here, this is going to be number of birds and cats. All of this right here. Highlight that red again. Okay, this is birds and cats. These are these people that are tormenting their birds by having them around cats. So what that represents here is this part of the equation. So it's going to be minus, so that's going to be both those rings, so that's going to be 2 plus whatever x is. So that's now minus 2 plus x. Now, it's got to be subtracting birds and dogs. So if I look at birds and dogs, which makes a little more sense, that's going to be this piece here. So that's going to be all of this, which is 3, plus all of that, whatever that's going to be. So that's going to be minus 3 plus x. And then the last ones for dogs and cats would be minus 4 plus x. Okay? So now what I'm going to do is I can add up things that are similar. So 13 plus 13 plus 13, that equals, oh, I also know the total number of birds and cats and dogs. The whole total, the whole shebang of people that owned all of them was 28. Right? Yeah, so 28 here equals, so 13 plus 13 plus 13 is 39. Now, with this negative sign outside the bracket, what you got to do is you got to distribute it to both. So that's going to make that negative 2, take away x. Same here. Negative 3, take away x. Negative 4, take away x. Plus x. Okay. When you're solving for x with this equation, it always kind of works out the same, that you're going to have extra x's left over, which is cool, so don't worry about that. So now let's combine our like terms here. So 39, take away 2, take away 3, take away 4, that's 30. Right? Yeah. Negative x plus negative, take away x, it's negative 3x plus x. Negative 3x plus x, which equals negative 2. X, now I just solve for x, so I bring the 30 over. So that makes this now negative 2. Negative 2x. One equals x. All right, so now I know how many people own all three. This is 1. Okay, so now I can figure out the rest. So if each one of these rings on its own has to equal 13. So this here has to be 13. This here has to add up to 13. And this here has to add up to 13. I can just work backwards to solve. So let's start with birds. So 3 plus 1 plus 2 is 6. Take 13, take away 6 is 7. So for cats, 1 plus 4 is 5, plus 2 is 7. So the number of cats has to equal 6, because 6 plus 7 is 13. And then finally, 3 plus 1 is 4, plus 4 is 8. 13 take away 8, that has to be 5. All right, and those are my answers. Okay? So now, so total number of people with one pet, yeah, 6 plus 7 is 13. Equals 5, plus 5 is 18. All right, so 18 people have, so how many children have one pet? I add up these numbers here. 18 kids have one pet. The rest have more than one, which makes sense. You got these guys, these guys, these guys. Okay, so those are my examples. So with 3-ring diagrams, read them out, take your time. It's going to be one of two things you're going to have to do. One, where you're going to need this formula, or two, where you're going to have to work backwards from the middle and work your way back. All right? People tend to like these once they figure them out. It's just a puzzle you kind of have to solve. So I'm going to give you some here to work on. Page 191. Let's go 4. I'll put in 2 in there too, that's right. And try 13. All right, there you go. Good luck.